Hello people, welcome to my channel Mohit Sai for you. This project is a PD controller for quadrotor motion in only one direction. I have uploaded all the project files in the GitHub, give it in the video's description, and if you want to work on it you can just download the code. Just look at the repository for more details. I don't want to go into deep details because this is the review of that project, like overview. This project's main goal is to understand the quadrotor dynamics. So let's get into the technical details of the quadrotor that I have. So here is an illustration. So this has a mass of 0.18 kgs and has a length of arm. Each arm is 0.086 meters. And these are the, to have it in the vertical direction. And here is the PG control input U, which is the thrust of the motors or for the quadrotor. And then this PD controller values KP and KV are tuned for only two distinct cases. One is to maintain stability at height 0, the other one is with a step input that we give. So here it has to go to 1 meter and then maintain that position. So the KP and KV values are only tuned for that performance. So this has libraries where all the helper functions will be there. This has all the parameters, and this has equations of motion, and this is a function like which converts the simulation state into a 13 element state vector. Another function 3x3 rotational matrix which is required for the quadrotor. Quad plot class defined here. This is basically for visualizing the quadrotor dynamics, and then position quad pos function which gives us the coordinates of the quadrotor. You can visit the GitHub repository for more details of all these things. The main functions are the controller, the PD controller, and so this is the equation that we saw. And we also have a Umax, so which is for the actuator limits. You can visit the GitHub repository for more details. And this is the fixed set point which will set the ZS and T. And this is the function like for simulating the height control system for the quadrotor. And this is the script file for the simulation setup. As I told, the KP and KV values are only tuned for 1 meter and 0 meter. So ZS is equal to 1 meter, okay? So let me run. Yeah, you can see there is a little spike, and then but the response is stable after some time. So after 1.39 seconds, it's almost stable. So now let me check with the 2 meters and see how the simulation goes. Yeah, you can see there is a huge spike, and then again there is very downward spike, and then the response was stable. So almost after 2 seconds the height is stable, so which is not a very good thing because the KP and KV values are not tuned for all kinds of situations like I mentioned. So you can download the code and you're open to tune the KP and KV values. And I have given a few more like what all you can do if in the future work. Just go through my GitHub repository and then feel free to contact me if you have any doubts. That's about it, the project. Make sure to like the video, subscribe and share for your fellow robotic engineers and students or your fellow classmates.